Hi, and welcome to the second video on differentiation. I'm using gradients of curves to find equations of tangents, normals, straight lines, etc. So here we go. We're going to be looking at tangents and normals to curves in this video. So here we go. Right, first question. So we've got to find the equation for the tangent to the curve at the point where it crosses the x-axis, and we've got that equation there, y equals 2x squared plus 5x minus 12. And we should be familiar with the concept of a tangent. We should know that a tangent is a line that just touches the curve but doesn't actually cross it. And the most important principle we've got here is the fact that the gradient of the curve and the gradient of the tangent are the same at that particular point. So the whole thing's going to be linked via gradients. So here we go. There's our curve and there's our two tangents. And as you can see from the diagrams, clearly as the curve crosses the x-axis in two places, that means that we're going to have to come up with the gradient of two tangents. So you can see them there, L1 and L2. So where does it cross the x-axis? Well, it crosses the x-axis when the y-coordinate is 0, so we've got to do some solving there, a little bit of factorising, and that's going to give us our two values, 3/2 and -4. So what we need now is the gradient. So there's our gradient function. A very straightforward job to differentiate that one. And so what we're going to have to do now is just take these values here and put them into our gradient function, and then we're going to get the gradient of L1 and the gradient of L2. So when x is 3/2, dy dx is that, which is 11. Now that we've got that, let's go straight for the equation of a straight line. Y minus y1 equals mx minus x1. And again, it is always a good idea to write down the equation that you're going to use before you actually use it, so you're showing the examiner you know the correct equation to use, and that will help you get method marks if something goes wrong later on. So now let's take the information we've got, which is we've got a gradient of 11, and we know we're at the coordinates 3/2, 0. So let's put those in. There they are. Y is 0, x is 3/2. Do a bit of tidying up, and there is our first equation of our first tangent. So that one, as it turns out, that's L1. That's that one there. So now let's do L2, and that's happening when x is -4. So when x is -4, we've got dy dx is -11. So same deal as over here, we just put a -4 in instead of that. And again, put it into the equation of the straight line, and there we go. There's our two tangents. Sorted. Okay, so moving on, we've got one that's slightly more complex this time. So we've got a curve that's got the equation y equals kx cubed minus x squared plus x minus 5, k is a constant, and we've got the point A, which has got an x coordinate of -2 that's on our curve, and we're told that the tangent at C is parallel, tangent to the curve at that point is parallel to the line with this equation. Now, again, with all these things, let's say you get a whole load of writing. It's a question trying to figure out what the heck is going on, so it's always a good idea to have a diagram. 9 times out of 10, you'll get that diagram given on the exam paper for you. But there we go. So what we've got is our curve C, which is the red line, and we've got our tangent at the point A, where the x-coordinate is -1/2. And what we're being told is that tangent there has got the same gradient as our purple line there. So we've got to work out the value of k. Well, our first job is to, if we can figure out the gradient of that line, that means we know the gradient of that line, which means we know the gradient of the curve. So that's the way into this one. So there's the equation of our purple line. Do a bit of rearranging, write it in the form y equals mx plus c. There we go, and we can see clearly from here we're going to have a gradient that is 7/2. And so what that tells us is the gradient of our tangent is 7/2, and it tells us the gradient of this curve is 7/2. So gradient of the curve, so we need to do a bit of differentiating. So let's take our equation here and differentiate it. So don't worry about the k there, that's not going to change. What's going to happen is we're going to be able to bring that 3 to the front, and so we end up with the gradient function for the curve. So we've got our gradient function in terms of k, so we're interested in what happens when x equals -1/2. So let's put that into our gradient function. There it goes. Tidy it all up, and we've got our gradient there in terms of k, and it's k the thing we need to find out. So we know, if I can get it to come up, there we go. We know that if the tangent's parallel to the line, then the gradient of the curve at x equals minus half is 7 over 2. So we know that our gradient function here, this thing, is going to be 7 over 2. So let's put the 7 over 2 in place of that bit there. So there we go. 7 over 2 equals 3/4 k plus 2. All we've got to do now is do a bit of solving. And when you do solve that, you find you get a value of k equals 2. Right, so that's part A done. On we go to part B. So if k equals 2, let's go up to our original equation up here and say, well, if we know k equals 2, that means our equation is y equals 2x cubed minus x squared plus x minus 5. We want the value of the y coordinate A. We know the x coordinate A is minus a half. So it's just a straightforward job to put minus a half into our equation, do all the tidying up, and we end up with y equals minus 6. Okay, sorted. On to our third example. So we're going to be dealing with a normal this time. So we've got an equation of a curve. Again, it's a cubic with some extra not particularly pleasant looking bits going on within there. And we need the equation of the normal to the curve. And we're told specifically that's the format we want the equation of our line to be in. Right, so there's our curve. Now, I know that looks more like a quadratic, but this thing is, I've just kind of chopped it and zoomed in a little bit because here's our cubic coming down here, goes back up. It would disappear off the top and then come back down again. So this is just a small part of our cubic curve. So it's not actually quadratic. That is definitely cubic. Like I say, I've just chopped part of it just to make it easier to see what's going on. And what we've got there is the tangent at the point we're interested, where x equals 4. Where's my mouse? Here it is. So when x equals 4, there's the tangent. That's the line that just touches the curve but doesn't go through it. And the one we're interested in is the normal, which is the green one there, and the green one that is at right angles to the tangent. So it's the equation of the green line that we're after. Now, as with all things, if you want the equation of a straight line, we're going to need two things. We need the gradient and the point on the line. The gradient is the bit we're going to have to find. The point on the line, we've already got this. It's 4 minus 8. We've got that in the question there. So let's see what we can do about working out the gradient. So clearly that's going to come from differentiating. So we know that the gradient of the tangent and the gradient of the curve, the gradient of the blue line and the red line are the same at that point. So let's use the gradient of the curve. Notice, here's my equation of the curve, and I've taken the 8 over x and written it as x to the minus 1. So now I'm set up to do the differentiating, and here we go. Bring the power to the front, knock one off the power, same again there, and same again there. Knock one off the power, notice that's becoming minus 2. Minus 1 is minus 2. And we also know at x equals 4, 8, x has a value of 4. So put that in there, and you end up with the gradient of the tangent. The gradient of our blue line is minus 7 over 2. Okay, so we know the gradient of the curve is minus 7 over 2. We know the gradient of the tangent is minus 7 over 2. We need the gradient of the normal. How do we find that? Well, we go back to that fact there, and again, it is well worth stating that fact before you actually do the working out when you're in the exam. And so we've got to flip it upside down, swap the sign, and so the gradient of the normal is 2 over 7. All we've got to do now is put it into our equation of a straight line. Y minus y1 equals mx minus x1. We've got the gradient, 2 over 7. We've got our coordinates from here, 4 minus 8. Put them in, and we're told very clearly that's the format we need for our answer. So we've just got to do working out. And again, let's take the 7 over to the other side and multiply it. It just makes that a whole lot easier rather than dealing with fractions. And then we've got to get everything on the one side and leave a 0 on the other side. There it goes. And there is the equation of the normal, which is what we're being asked for. Job done.